In this session, we are going to cover how we can achieve multi-vendor service assurance with Crosswalk Network Controller using OpenConfig and GNMI. Hi, I am Krishnan Thirukonda and I am a principal engineer in the Crosswalk product team at Cisco. Let's start by reviewing what we want from automation. These are provisioning, visualization, and service assurance. We want to provision new services, we want to be able to see them, and we want to be sure that the network and the services are working fine. And all of these need to work in multi-vendor networks by our large customers. So let's review one by one. Provisioning services, that's easy because we have our product that is probably familiar to all of the folks attending this session. It's quite a powerful platform to build extensible services using model-based approach and a declarative paradigm. While at a detailed level there is a lot more to be aware of, if we simplify it, we can say that it does transformations between models. There is a service model that abstracts services, and then there is a device model that actually represents devices. There are transformation code that's usually referred to as fast map in NSO terminology and is implemented by the automation developer using templates and some code using either Java or Python. To support multi-vendor, then the southbound layer of this platform, NSO provisioning platform, or any platform for that matter, needs to have an interface into all the device types that it supports and should be able to talk to those devices using the native protocols and its specific behaviors. With NSO, as most of us may know this, the component that talks southbound to devices is called a network element driver, referred to as a NED. And NSO does support a large library of NEDs. Over 170 types of devices are supported. Once the provisioning is done, then we are in operations phase. From operational point of view, visibility increases efficiency very significantly. How can we quickly look at the topology and see if there are any problems? What services are deployed in the network, what paths traffic will take, with or without traffic engineering, and so on. Doing this by logging into device by devices is very cumbersome, and most folks are building some way of seeing this by themselves. Humans are very visually oriented and can process lots of information when presented visually. It turns out to be actually a very hard problem to develop such tools and not only keep it working as new technologies and new devices are introduced, also we want these to be dynamic. That is, when the network and services are changing, we want actually to provide this visual representation also updated without any additional development or change required. This is where Crosswalk Network Controller comes in, and it sits on top of NSO. We have other sessions that we have presented where we have described the architecture of CNC and how NSO is a big part of it. NSO is a configuration engine, and CNC has a visualization engine. We call it Crosswalk Active Topology, which merges a lot of the information. For example, information that is coming from the topology, layer 3 topology using BGP link state, metrics from SNMP and GNMI and telemetry, traffic engineering paths through PSAP. All of that is actually merged and presented in a nice to understand view for the networking engineer and the operations engineer, so that they can see a topology with all the important information overlaid on that particular topology view, which is how network engineers think. So this layer is very agnostic to the actual underlying devices and the individual components that are controlling the underlying devices for different areas. For example, the traffic engineering part has abstractions to work with other vendor devices, and then for telemetry collection there is a similar adaptation layer. Finally, let's look at service assurance. When we talk about service assurance on Crosswalk Network Controller, let's first understand that it's based on an approach called service assurance for intent-based networks, and this is actually standardized in IETF at using RFC 9417. The way it works is that CNC service health uses service config that's actually as service create update deletes are coming into the CNC system, which is all backend by NSO. There is a set of rules that is triggered automatically to calculate telemetry KPIs that will give us service specific health information, right? And these KPIs are then proactively collected. We trigger collections to go collect these KPIs from the nodes in play for that particular service. And then we calculate the service health using the values that we are using for KPIs and running it through a logic. The end result is that we get a service health up or degraded or down, kind of a rolled up status. The idea is that if you ever want to troubleshoot a particular issue, you would go manually, you would log into each router by router basis, and you would use your knowledge to go and do what typically are called as show commands using CLI. You do show BGP summary, show BGP session state, and so on. And this would basically manually and using your own networking engineer intelligence, you would conclude whether this is a problem or not. But what we are doing here with this particular approach is that we are writing a set of rules which can be extended, where we are saying that for each type of service, it depends on a certain subcomponents, the service dependency graph we call it. Each of the subcomponents are basically collecting a few KPIs and applying a logic, and then basically we are determining if that subcomponent is good or bad, right? So typically, like if you think of a L2 VPN, then is the attachment circuit up? Is the BGP session, if you're doing EVPN, up? All of those, you can think of them as sub components, and you can check each of those by, if you're doing manually, by doing show command or collecting the equivalent KPI through SNMP or telemetry. So when you go ahead and create a service, the CNC system looks up what type of service you're creating, looks up the service dependency graph, and instantiates a particular, for that particular service instance, a service assurance instance graph, which is basically a state in the system where each logic is being applied to a specific set of KPIs, which are also collected. Now this is ongoing, meaning every so often we have a periodicity that depends on type of KPI, and then we periodically collect all these KPIs. We run it through the logic or the assurance graph on the left that you see, and the end result is that you get a degraded or good or bad, right, up or down status, as well as when we have degradations, which particular component is degraded, and in a textual format, right, so that the operator who's looking at it can understand what has gone wrong and potentially go try to fix it, or call somebody from the escalations team who knows how to fix it. And once we have all that information, we can assist with the resolution process as well, right? So now we can say, okay, here's what we're seeing now. How often has it happened in the past? You can do historical views. You can also trigger notification to external systems to raise tickets or to trigger remedial actions and so on. So this is very powerful. The idea is that the knowledge that experts have, the people that are designing your services, can also go ahead and capture the troubleshooting steps and put that information in a machine usable form, and this is what we call as the service assurance model. And then this is triggered and when you create update services and you collect service health information and present it to the operator, who actually doesn't have to be requiring to go do it, doesn't need to have the knowledge, doesn't need to have access to the routers, and when the problem is triggered, proactively we indicate along with the log of everything that we have done, right? So that saves a lot of time, saves a lot of fatigue, and makes it easier to manage networks. So in this session we are going to see how in CNC service health, how can we add a different vendor router and also do service assurance on that, right? So CNC out of the box, it includes support for CNC, Cisco IOS XR and IOS XE, but it is designed to be extensible. So in this session, what we'll talk about is how we added an example, let's say, of how we added to show you the capability of multi-vendorness of CNC. So in this case, we are going to use a Junos virtual router running 22.3.R11, and then we are going to discover it on CNC, and we'll talk about what configs we added to get that to work. Then we're going to talk briefly on the second and third item on this slide, which is the NSO side changes to extend the L3 VPN service, which is called as L3 network model function pack. And then this is going to now configure L3 VPN on the Junos router. And we are also extending the core function pack with the segment routing TE that ships with CNC. It's called the TSDN core function pack. We're going to extend it to support also the Junos variant of SRT using the on-demand next hop templates. Finally, the bulk of it is going to focus on the service monitoring. Once the service is deployed, we are going to actually edit the rules, which we are calling as custom heuristic package. We have an out-of-box what we call a system heuristic package, and now you can go ahead and edit it and customize it to your particular in this case only the southbound router has changed, router type has changed, so we're going to see we can that's what we're going to see. Now note that in the CNC there is also a visualization function pack which is running inside the active topology. That part doesn't need to change because we have not changed the northbound model. It's only the southbound device has changed, the same exact northbound model, so that's why there is no change for that. So when we added a VMX, we called it VMX 99, a virtual Junos router in this topology, and all of the other routers are IOSXR V9000s, right? So you can see that we have the topology discovered, and the way this works is that we basically configured ISIS and BGP and PSEP. So let's go to the router, to the live setup. So this is the CNC system, and here we have this is running CNC 5.0. Let me go to the topology view, and in this topology view you can see that we have all these routers. So this is the Junos router that's connected to node 1, and on the left you can see here that we have the type of router detected, and you can see we have a few iOS XC, a few iOS XR 9000s, and then we have the Junos that's over here, and then we have some metadata about its location and things like that that you can add. This discovery part depends on BGP link state to detect all your layer 3 links from ISIS or OSPF that you're running, and ingest them. So next thing what we'll do is to go ahead and provision an L3 VPN. L3 VPN based on the RFC 9182. So CNC we have adopted the IETF based layer 3 VPN model, network model, and that requires you to create a particular structure. There's a YAML that defined, and CNC uses that. So if you look at the picture on the right, what you would do is you'd go ahead and create a route policy first, and in that route policy you can create, using destination and source prefixes, a mapping to a route policy tag, which is basically going to set a BGP color community on those VPN v4 and v6 prefixes. And finally, the route policy, once it's created, you have to also identify it as suitable for L3 VPN using a VPN profile, right? So all of that's already done in this demo, and then you create the L3 VPN, right? Now, before we go into too much detail, what I'll just briefly talk about is that the NSO TSDN function pack that ships with CNC, it has the Cisco ISXR and ISXC capabilities, but it also has a way of a hook into implementing a different vendor southbound implementation, right? Which is what we have leveraged. Now, we showed this already in a previous developer days, and please, if you are interested in understanding more details on that, you may want to go and look at the YouTube link, which has a recording of what we showed earlier on how to do this part, right? So this part's already done, but this is just a reference for you. And then finally, the code that we used in this demo, the NSO core function pack extension code, you can actually go download it from GitHub. My colleague has developed or uploaded it there. And so these are the demo packages we are using in this demo, but if you want to play with it yourself, you can download it and use it as well. Okay, so now let's switch back to the live demo here. And let's go into VPN services here. So we have created one VPN. If you click on this VPN here, this is the visualization that you see for this particular VPN. You can see there are 4 PE sites. 3 of them are iOS XR, and then there is a Junos router here, VMX99. When you go and click on the view details part here, you can see that we'll come to the health in a bit, but let's go ahead and look at the transport. So we have bound these 4 PEs to use a BGP color community, so there is SRTE, MPLS SRTE running underneath, and you can click and see from every router to every other router, which paths will be used, right? So that's the power of having a single IP SDN controller managing all of your services. So for example, from VMX99 to to Node 5, let's pick a longer one. You can see that this is the path it goes, and you can actually see the details on how it was created. These are the traffic engineering views. And you can actually see that the Junos router calls the dynamically generated path in this kind of format, and it has 2 IGP adjacencies, a bunch of information at fingertips just by clicking, right? The ops team that is managing networks doesn't need to actually log into any router to get this kind of information. So this is really the power of visualization. There's another piece to look at, which is history. We actually automatically meter how much traffic is going through these policies, and we can show you the details here, as well as any path changes that have occurred. So the intent might say that this service should use the lowest latency path or an affinity to something, and then we can actually show the any change in the topology will automatically cause re-optimizations. So all of those events are shown here. So let's keep moving. Let's go back to VPN services. So the next thing to look at, let's go back to the slide. We are going to enable service health monitoring. So to enable service health monitoring, we basically have to go and click, in this case I've already enabled it. It does take a few minutes, 5 to 10 minutes to build up the full state of monitoring. We do KPI collection, particularly when we are doing SNMP or CLI at a very non-aggressive timelines. It's a 5-minute kind of intervals, and sometimes to do periodic checks to conclude, we need at least 2 samples, so it takes up to 10 minutes to build state. So I have this already being monitored. As you can see, there's stop, pause, and edit monitoring settings. So we can actually go ahead and look details again this time. And right now you can see that the service is degraded, which means service health module is saying that the service is actually degraded. And then you can actually see what are the symptoms. Why is it saying degraded? And you can see that it's very easy to understand language here. You can actually hover over it, but I'll make it easy to see it by just moving it to the right. So you can see that now we are saying that each of these sites, customer sites, PE sites, sorry, we actually expect to have a eBGP session to a neighbor, the customer router in that VRF, and they are all down, including the one on Juniper, right? So we are detecting that these eBGP sessions should have been up, but they are down, and that's the active symptom, right? So let's go back here, and then if you go back into assurance graph view, here's where you can see all of the things that are being checked. You can go ahead and expand all, and these are the full assurance graph checks. And you can see that there's and you can actually, let's also click soft dependencies, and then you can see that there's a number of things here. Let's make it bigger slightly, and you can see that these are the full set of things we are checking, and the types of checks we're doing are in the first circles on the top. This is the assurance graph view, right? The dependency graph. VPN 101 service health depends on a few types of checks, and each type of check may have another child node. Either the child node is directly referring to a PE, in which case you can see that we are also checking it on the Junos router. We're checking the PSAP session state because we have detected in the config.db that there's a binding to a SRT policy. Let's go ahead and check PSAP session. That's what the rules says. So we're checking that on the Juniper also. Interface health, it makes sense. PEC interface, is it up or down? Are we getting packet drops on that interface? All of that. Now this is a soft dependency, that's what the dotted line means, and here we are checking whether the device CPU, memory, and things like that are across all of the services on that node. It's a node level health, so that's why we call it device health. is that good, healthy or not, right? And finally, we have also PEC route health, where we are checking that the routes coming from CE, and then we are feeding into some other checks here. But the main reason why it's degraded is, as we saw in the textual explanation, that the BGP session is down, right? Now this BGP session is down because I don't really have a CE router connected. And that's it's easy to see that this is super useful in that case. You can also go back into I clicked on show history here, and you can actually see what's a trend of this in this past. So you can see that here's the eBGP session down symptom, and you can actually click on that to see the last 24-hour metrics that we automatically cache when there is a degradation issue. In this case, you can see that the BGP session itself has been flapping between connect and active. It's never gotten to established, which is a good one. Active means actually trying to connect, and these are the two states. It's flip-flopping, trying to connect and actively trying to connect. So basically, it means that this session never came up in the last 24 hours. This is another super useful feature on CNC. So let's go ahead and see what did we do to make it work with Junos, right? So like I said earlier, there is a structure to the service health rules package, which is what we're going to look at next. But just to step back and think about it in terms of how would you make a new type of device work with this rules package. As you might expect, the out-of-box rules package has a set of KPIs that will get a certain set of information, things like interface state, BGP session state, all of that for Cisco IOS XR. If you're trying to add another vendor, you need to go get the similar KPI for that vendor. The preferred approach is that you try to use OpenConfig models and you use the GNMI mechanism to get that KPI for that other vendor. Why? Because GNMI is a standardized method, and OpenConfig models are also getting standardized. It's not as rich and fully featured at this point, and vendors are choosing to do very simple models for like interface health and device health is easy to get. BGP is a very popular one. So as customers are using and demanding, vendors are meeting and expanding, right? There is no point in time where it will ever be complete because it's a moving target, right? As new technologies come up, new OpenConfig models will be needed. But at the moment, we see it's a little bit sparse on advanced stuff, like things like SRTE. Some of this standardization is happening, but vendor support is coming, right? What that means is that there may not be all KPIs that we support on XR on the other vendor, but there are of course means of ignoring it. And this may be that you can actually collect something that is platform specific as well, and that may not apply to the other vendor implementation of that route, or either hardware KPI or even the technology the way it's implemented. You can use SNMP metrics as well. In CNC, currently we use a SNMP to YANG module, and you can convert an SNMP MEB that may be an enterprise MEB, which is specific to that vendor. You may have to run it through these steps that I have linked here. In this demo, I don't have an example of that. The other thing you can do is to also collect metrics using CLI. This should be literally the last resort. And we have a SDK to develop CLI packages. At the moment, it's not documented or publicly exposed, but you can get this done through our professional services. But we are also considering to make it publicly available. That's still being decided. Finally, there may be some things that you want to do special for certain vendor routers versus other routers. And what you will see is that we actually apply the rules logic using the config DB in XML, and we do expat queries, and there are some knobs that you can use to filter out certain things. And then what you do is that you first find the equivalent KPIs, right? You choose whether, if you're lucky, you will get an OpenConfig KPI on the other vendor, and then it's actually relatively easier. If that's not supported, then you have to find an SNMP MEB. Hopefully that is either a standard MEB or an enterprise MEB, and you run through the conversions method to create the device SNMP packages and load it on CNC. And if that's not supported, CLI is an option, as I mentioned. If it's not feasible, meaning you still don't have that information, you're waiting for your other vendor to give you the detail, but you want to get started, you can always stub out a few KPIs by saying not supported, or if it's never going to be supported, you can always leave it like that. And then you can actually create collection jobs using CNC's collection API, and to see if you can actually collect this KPI, and you may have to write some small tools to actually see that the data you're getting out of CNC collection matches. There won't be enough time to go into those scenarios in this session, but we can create we can show. Basically, it requires you to use the CNC API to collect and publish to Kafka, and then you read out of Kafka. There are some sample demo packages that we have developed that you can use to quickly test any kind of collection and see that the data you're getting is what you're expecting. Once you got the KPIs identified, then you have to make edits to heuristics package, and what we'll do is we'll publish this example that we develop here, and then you can actually see this. So in CNC, we have a concept of basic monitoring and advanced monitoring. Basic monitoring does a few KPIs. It does device health as well as PEC. In the VRF, we check just one parameter, whether it's has enough routes as expected or not. Right? It's a very simplistic check. It scales very well. That's why we call it basic monitoring. And then you can see an UI snapshot here. I'll switch to the live system to show advanced, because I didn't. I switched it over to advanced. Before we go there, let's finish this part, which is what did we do to make the L3 for this L3 VPN package, the basic system to work. So the basic system, let me go back one slide, is actually going to check device health, which is going to check CPU and memory. It's going to check that in every VRF there are connected routes for the PEC interface. And the way you do it is you basically edit these files called metric to device.cpu.load, and then you add a block for Junos, because we can go detect this router is Junos type using a query to the SNMP system MIB parameter, which we do for all devices. And if the Junos type, then we go and get this OpenConfig system CPU state total instant, and then the value that's returned by that is the CPU usage. And then there is the second one is the components component for routing engine 0, and there's a memory available. Right now, this which OpenConfig item will give you the value you want. This is something you have to do a little bit of research on all these OpenConfig models, understand and try it out and see. There is no easy way to do this. It just has to be looking at the OpenConfig documentation, the vendor documentation, and then the do the show command that you're probably familiar with, and see that you're getting the exact same value. At that point, you know that you got the correct value. You can set thresholds to detect alarms, so those thresholds are set in this format. So basically, it's a low-code environment where you're actually creating JSON entries into the heuristic package file. And then here's an example of getting the total prefixes in the VRF. So you go ahead and get the prefixes, and we are comparing it that it's more than 0, so you at least have a connected route. Right? Very simplistic implementation, but this is just a demo. You can do anything you want. As you can see, the concept is what I'm trying to explain. So now let's go into advanced monitoring. So advanced monitoring does quite a few things, right? So we can in this UI example, so you can see that besides doing device summary and device route PEC route health, we have added the check of BGP neighbor health, eBGP neighbor health. So we are checking whether that for every VRF where we were only checking connected routes existed, we have added a check if there is at least one BGP session, right, to the neighbor that's actually configured to the L3 VPN payload. That will be the CE router, right? We do have the device health, which is the same as before. Interface health now shows up. In interface health, we are checking that the PEC interface is up, and there are we can check a few more things, packet loss, discards, and things like that. And we'll talk more about that. We also have detected that there is a binding to a SRT session, but you can see, interestingly enough, we are not checking it on the Junos router. And the reason is I wanted to show you that that's possible. So let's go ahead and look at how we implemented this, right, and how it looks when it's degraded. So the BGP neighbor health is very similar. We have an OpenConfig, path that we can get and we can check. And then here's the thing that we are saying that some of these KPIs that we are looking for on Cisco XR do not apply. So you can actually put a not supported equals true in the heuristic package, and then you can see that that will be ignored. We won't be collecting that. And here's another example of how we actually ignored the check of PSEP session on the Junos router. One of the ways you can do that is that you can say that subservice, the subcomponent that checks PSEP health, we can make sure that the PSEP session health subservice does not apply to Junos by putting this XPath query saying that it only applies to certain nodes of certain pattern. Now that's a kind of a shortcut we took in the demo, but in theory you can attach different metadata to your L3VPN payload and somehow use any of those things to detect which type of nodes this particular check should be done on, right? So this is just one way we are showing. Let's actually cover this and look at the overall final thing. So to do the CLI collection, and it turns out that the PSEP connection on Junos could not be done through GNMI, so and I believe through SNMP also. So we actually decided to use a CLI method to get that parameter, and to do that you have to develop a device package for CLI. There are specific steps to do that using what we call as XD-PAL SDK. At the moment, like I said earlier, it may need professional services help to get access to that package, and they can train you and then you can use it, and so on. So that the best way to understand more about how you can get access to that may be through your account team. But once you have access to that, and we have internal documentation that we can provide you as part of the training, you can create this device package, and it uses some Java code. At the end of the day, whatever you develop will be bundled into a tar.xc file, which you can load it into the CNC system. Once you load it into CNC system, it will register the support for certain CLI commands. And those CLI commands can now be put into the rules engine of service health. As you can see here, these names are, by the way, is how the device package was implemented, and you can then now go get and extract certain values out in the output and show it here. And this is basically then adds the, once we added that, we were able to see that the PSEP session health on the Junos is also good, right? So now let me switch to the demo system, and basically this is what I was showing. You may not have realized it. I was showing you that we were doing advanced checking with all of these checks being done. Let's go back to assurance graph view, and then you can see that we have PSEP session health. Let's expand all. Let's move this to the side, and you can see that we are doing all of these checks. You can add the soft dependencies, which is it's called soft because we're not sure this impacts the service, but it may, right? So that's why it doesn't always show up. You can see it, but then we are checking interface health, PSEP session health on VMX, and all of that. Now, how did we actually edit this? Where are the rules engines living? I should have probably covered this earlier, but let's go take a look. If you go into this part of the screen, it's called heuristic packages. This is where all the rules live, and you can actually click export here. This is a package that we developed and we loaded, and you get a tar.gz file, right? You can open up the tar.gz file, and this is where I have it here, and you'll see that there is a, when you untar it, you see all the files in this place. And then here's the metric class, and this is where we, the example that I showed you for example, the device CPU collection. You can see here the actual file, right? These are all JSON files. There is a way of using some code to do certain more complicated manipulations. We call them the Python plugins for service health, but I have not really needed to use it. So I wanted to make the point that it's very low code environment. You do have to edit JSON files and be comfortable doing that. A lot of the actual time goes in identifying which KPIs will give you the information you want, and the rest of it is actually quite easy because you're just adding editing this file, you're cutting and pasting these blocks and making them. Of course, we are trying to build developer aid tools here, like IDE plugins um, or even a nice GUI based SDK, but we are not there yet. At the moment, this is how you have to do it. Again, as you can see here, we have implementation based on the type of router and the mechanism, right? So iOS XR generic, and then you can actually give precedence, right? You can say use the higher precedence method will be used for iOS XR. For example, we have two methods. We can use it. We are actually preferring to do SNMP just as an example to show you. But on Junos, we are getting this value using this OpenConfig path. We'll be documenting a lot of this in our public documentation, but right now for the demo, we won't be able to go into too much detail on the syntax of each of those items. Another one to show you would be a metric for the PSEP session, where I said that we are using CLI. So let's go ahead and look at that. So here we have, again, I can do a quick search on Junos. And then if it's Junos, we're going to do a CLI metric. We're going to do a show path computation client active PCE, and here's the XML file. This is how the package is built, and you're inside the package, you're picking one of the functions. So that's the way to do it. Here's an example of how you can actually create a KPI that is not supported. So if you search in this, for type Junos device, this KPI is not supported. Okay, so going back to this presentation, we are at the end of it. So wanted to show you that we can actually use API calls as well to create the config profile metric class plugin, the one that we were editing. You can also do updates if you create your JSON payloads, and you can use Postman and other tools to update these things. But in the you can also go ahead and export the file, edit, and then import it, right? You can also see all of the items on the UI here by clicking on I here and just viewing it here. You can see the JSON. With that, I think we are at the end of this presentation. Please feel free to reach out to us for any questions through the Automation Developer Days. Thank you so much.